All right, so we only have one exercise for the undirected graph because it's so familiar or similar to the other ones with the directed. So start working on this and we'll go over an answer here in a moment. So this is actually the second time I've done this. So I'm going to put it as a gag reel for the next video, but you'll notice I screwed up somewhere and I realized it only because I double checked, actually a number, well, how is 4 connected to 1? And it wasn't right. It's a good thing I did that check because otherwise I wouldn't have figured it out. So please make sure you watch the next video. I'm going to try to shorten it up a little bit because you'll see most of the answer being done correctly. But then you'll see me screw up in one spot and notice go through everything and then I come back and check and go, uh-oh. So watch that in the next video. So anyway, so hopefully I'll do it right this time. Is that again, we're starting off with 1. So I've already preset some values and put 1 into the queue. Now, I'm going to go ahead and look at what 1 is connected to, which is going to be a lot more compared to what we're used to with the directional graph. I'm going to try to do it in order, too. So it's going to be 0, 3, and 5. Now, what I'm doing is I'm kind of doing 2 things at the same time. Number 1, I'm checking to see if it's been visited already. So you'll notice I kind of use my hand to kind of check to see if things have been visited for that particular node. And then I also put them onto the queue just to make sure. So now 0, 3, and 5 all came from 1. 0, 3, and 5. I set those all to true. Okay. Now, so we're done with that. We did our update. Now we do our drop. Okay, at 0, and this is where I screwed up on the next video here. 0 is connected to, in order, 1, which is already done, and that's our lead node. 3, which is already done, already been visited. And 4. Okay, so we're going to add 4 to this. That was visited by 0, and then set to true. All right. Any other updates? 0 goes to 1, 3, and 4. Nope, that's it. Okay, drop 0. Now we go to 3. 3 is connected to 0, which is already done, then 1, which is already done, and then 5, which is already done. So, yeah, no kidding. Okay, yep. So 3 really didn't have anything done to it. Very interesting. All right, 5. 5 is connected in order to 1, which is done, 3, which is done, 2, which is not done, visited from 5, now set to true, and then 7, which is also, I'm going to put 7 up here. Okay. So that's done. All right, that's the update. I think we're all done with that. Yep, I think so. Go ahead and drop 5. Now we go to 4. 4 is going to be interesting now. Excuse me. 4 is connected to 0. 4 is connected to 2. 4 is connected. Hey, there's a new one. 6. That came from 4. Set to true, and I'm going to add 6 up here as well. All right. Now from here on out, things are going to start being done. I mean, look at the list that we have here. Everything's said and done. The bad part is you and I have the gift of overall sight. We know that, but the computer's going to keep doing the same thing over and over again until it has none left in the queue. That's why the queue is so important, and frankly, so are the lists beside it. All right, so I dropped 4 because I'm done with it, but we're going to see a lot of drop and goes, as I'll call them. So now we go to 2. 2 is still, it's still connected to 4, 5, and 6. 4 is done, 5 is done, 6 is done. Nothing to update, drop and go. 7. 7's only connected to 5. 5's already done. Drop and go. 6. 6 is connected to 2 and then to 4. Both of those are done. Drop and go. So notice this last few, or almost 4, I believe, too. They were all done, and that's very different than maybe the previous algorithm when it's directed, but we're still using the same steps and all that good stuff. Now, here's where I screwed up. Let's double check this. I want to double check that this is correct. So what I would do is I'm going to see what my path is from 4 to 1 or 1 to 4, but we read it backwards. 4, and by the way, they did one of the shortest paths too. From 4 to, let's see, 1, I'm going to do it this way. 4 would first go to 0, and then 0 would go to 1. So 2 paths, or 2 links, or 2 edges, whatever you want to call it, to get to 1 is the shortest way. And if you look at that, yeah, that looks like the shortest path to me. All right, let's try 6. 6, you would go to 4, then 4, then you would go to 0, and then from 0 to go to 1. Yeah, that makes about sense. Okay, so notice that's how I checked my answer. That's also how I figured out that I screwed up in the next video that you're going to see. So heads up on how to solve for that, and heads up on what errors you can make, you and me.